Hello guys, welcome to our YouTube channel. Welcome to AdMaths Plus Maths. We are now going to discuss another lesson in additional mathematics, which is a part of the chapter 1 functions, definition of function, domain, and range. So we will be discussing more about domain and range over here because I already discussed the definition of function on the first lesson, which is mappings. Okay, if you want to know more about mappings, you have to watch that card that I'm going to put on top about mappings. Okay, so let's move on and recall what is the definition of function. The definition of a function: to be a function, a mapping must be many to one or one to one. So every input value, x, must result in only one output value of y. Picture this out. I will just recall the pictures of the diagrams. The left side is your domain and the right side is your range. So I called now domain and range. The input values are what you call the domain, and the output values are what you call range. So if it is a one-to-one, it is a function. If it is many to one, then it is a function. But if it is one to many, then it's not a function. So basically, this is the definition of a function. So let's move to some examples of identifying what is the domain and the range. I repeat, domain is the input value x, while the range is the output value y. Example number 1. F of x is equal to 2x minus 1, where x is a set of all real numbers or an element of all real numbers, where x should be greater than -1 but less than 3. Should be greater or equal to -1 but less than or equal to 3. Okay? First question, write the domain of the function. The domain of the function is already given. That is what you call the restricted domain. Since the restricted domain is already given, then the answer for letter A is as it is. X is greater than or equal to -1 but less than or equal to 3. Next, sketch the graph of the function. If I want to sketch the graph of a function, you notice that the function is a linear equation. And linear equation will always have a format of y equals mx plus c, wherein the c is your y-intercept. So if I want to look for the y-intercept, I am just going to take a look at that c. And in this case, y is equal to 2x minus 1. -1 is your y-intercept. Thus, y-intercept is 0, -1. Now, let's look for the x-intercept. X-intercept is when y is equal to 0. And if y is equal to 0, I'm going to change that. It will become 0 equals 2x minus 1. And -2x is equal to -1 if I will subtract both sides by 2x. And x is equal to 1/2. If x is equal to 1/2 and y is equal to 0, then x-intercept is 1/2, 0. Okay? If you are to graph the line or the function 2x minus 1, then you will just basically consider the x-intercept and the y-intercept. Connect those 2 points. By the way, you recall that x-intercept is a point on the x-axis and y-intercept is a point on the y-axis. Okay? So there are 2 points, and 2 points always determine a line. After finding those 2 points, just connect and you'll come up with this graph. But remember, we have a restricted domain, which is from -1 to 3. So if we want to graph the function, you have to restrict your graph from -1 to +3. So our final graph will be the one inside the box for letter B. Okay, notice that I have from -1 to +3 only. Okay, next, letter C. Write down the range of the function f. If you want to write down the function of the range of the function f, I am going to consider the graph. Okay, remember when I say range a while ago, these are the output value y. So what are the values of the y? You notice and study the graph. The final graph with the restricted domain. You will notice that from -1, the equivalent value is -3. Okay? And -3 is included in the graph. Next. And then for +3, the restricted value of y is +5. I repeat, for the restricted domain 3, the restricted value of y is +5. Thus, you will notice that it comes from -3 to +5. I repeat, the range value or the value of y will come from -3 to +5. Thus, our answer is y is greater than or equal to -3 but less than or equal to 5. Let's move to work example number 2. The function f is defined by f of x is equal to -2 x times x minus 2 to the power of 2 plus 3. For x should be greater than or equal to 0 but less than or equal to 6. So the restriction is only from 0 to 6, and we will consider that later on. Now, the first question says, sketch the graph of the function. Remember, I have a quadratic function. And when we are studying quadratic function, we know that a function, if it is a quadratic, can be written as a times x minus h squared plus k. If it is written like this, I can identify that the h and the k values will be your turning point. When you say turning point, in other countries, they call it vertex. I repeat, when I say turning point, in other countries, they call it vertex. And you notice, our function is equivalent to x minus 2 to the power of 2 plus 3. There is an invisible value of a, which is 1. Okay? If the value of the a is positive, then it opens upward. If the value of the a is negative, then it opens downward. In this case, the value of the a is positive, that's why it opens upward. And the value of the h, x minus h. You will notice that the value of the h now is 2. And the value of the k, okay, plus 3 plus k means the value of the k is 3. Thus, we'll give you an idea that the turning point is 2, 3. So, our turning point will be x value is 2 y value is 3. Now, to find out what will be the y-intercept, you make x equals to 0. I repeat, if we are looking for y-intercept in any form of function, let us make x is equal to 0. If x is equal to 0, y is equal to 0 minus 2 to the power of 2 plus 3. And 0 minus 2 is negative 2. You square it, it will become 4. 4 plus 3 is equal to 7. Thus, the y-intercept is 0, 7. And if you change it with the value of the 6, you will already find out that it will become 6 minus 2 is 4. 4 squared is 16. 16 plus 3 is 19. Okay? Thus, we'll give you an idea that the graph will look like this. Okay? You notice that if it is 6, it will be 19. If it is y-intercept is x is equal to 0, thus 7 is the value. And then we have the turning point over here, which is 2, 3. Then you will have the graph. It is supposed to be continuing over there, but remember, there is a restricted domain. Okay? Now, if there is a restricted domain, there is also a restricted range. And you will notice that what is the lowest point over here? The lowest point is 3. I repeat, the lowest point is 3. It is based from our turning point. The lowest point is 3 and the highest point is 19. Thus, the range of the function wherein the restriction is from 0 to 6, or the restricted domain is from 0 to 6, the range will be from 3 to 19. So y is greater than or equal to 3 but less than or equal to 19. I hope we were able to explain this properly. Now, let's move on to some past year questions. The function f is defined by 2x plus 1 squared minus 3. For x is greater than negative 1/2, okay, the restricted domain is x is greater than negative 1/2. Okay, if x is greater than negative 1/2, and I want to change and I want to look for the range of f, okay, remember I have here this function. I can change that x value with negative 1/2 to find out what will be the range of f. So 2 times negative 1/2 plus 1 to the power of 2 minus 3. You will notice that the y will be greater than or equal to negative 3. Okay? Why? Because 2 times negative 1/2 is negative 1 plus 1 is 0. 0 squared is 0 minus 3. It will become negative 3. Thus, your answer is y is greater than or equal to negative 3. Okay? If there is no restricted domain, then we can find out first what is the value of the h and the k. I repeat, find out first what is the value of the h and the k by expanding this and then transforming it into a times x minus h squared plus k. Why? Why do I need to expand this? Because you will notice that I have 2x over here. But since we have a restricted domain already, then we don't need to do that. We can just substitute the value of the x and find out what will be the value of the y for that domain. Now, if you want to verify if your answers are correct, then you can replace that x with 0, and positive values, because everything that is greater than negative 1/2 are positive values, and it can be 1 over 4, negative 1 over 4, it can be 0, it can be all positive values. So verify that answer. This will give you a 1 mark in your exam. Next question. The function f is defined by f of x is equal to x plus 1 squared plus 2, for x is greater than or equal to negative 1. Find the range of the function. You will notice that in here, negative 1 is your h, and your k is positive 2. Therefore, the lowest value, or the lowest value of the y will be positive 2. It will give you an idea already what will be the range of the function. But if you want to make sure, you can solve it this way. Range of f is equal to y is greater than negative 1 plus 1 is 0, squared is 0, plus 2, y is greater than 2. Let's move on to the next example. Function f is defined by f of x is equal to 2 plus the square root of x minus 3. For x is greater than 3, find the range of f. You will notice that the restricted domain is x is greater than 3. I can again substitute that x with the value of the 3. Okay, 3 minus 3, okay, will be 0. The square root of 0 is 0. 2 plus 0, y is greater than 2. As simple as that, your answer will be y is greater than 2. Thank you for listening. This ends the lesson about definition of function, which focuses more on domain and range. Please don't forget to subscribe if you haven't subscribed yet. If you have learned something from this video, please click that like button and share with your friends.